When I talk to people about my research, before they walk away, they're often surprised to find the fact that diabetes causes blindness. But it's an important fact, because every 3 hours in this country, somebody loses their vision from diabetic eye disease, making it the most common cause of blindness for young and middle-aged adults. And with the prevalence of diabetes increasing worldwide, especially in poorer countries where access to eye care can be scarce, diabetic eye disease is poised to become a global health crisis unless an intervention is developed, which is where my research comes in. I study the light-detecting tissue at the back of the eye, called the retina. And the retina is made up of 3 kinds of cells: the neurons that encode the visual scene and pass it back to the brain, the blood vessels that carry nutrients to these neurons, and the less well-known glia cell, which are like the guardians of the retina, keeping things running smoothly. And their job is to control how fast the blood flows within the retina to make sure the energy demands of the neurons are met. So after getting diabetes, for reasons we're not sure of, the neurons stop getting enough nutrients and they begin to starve. And similar to how a tree that's not getting enough sun will try and grow new branches to collect more light, the retina tries to increase supply of nutrients by sprouting new blood vessels. But unlike a tree, which is great at growing branches, the retina is rubbish at growing blood vessels. They grow out of control and they leak, which causes visual symptoms like this. And currently, this is when you would receive treatment to try and undo the damage, but it doesn't always work and the vision is lost. So I look early on, after getting diabetes, and ask the question, why does this starvation occur at all? And to answer this, I use a drug that gives diabetes to rats, similar to type 1 diabetes in humans, and I compare their eyes to the eyes of rats that haven't received the drug. And I conduct an experiment where, while looking into the rat's eye with a special camera, I inject a tracer into the peripheral bloodstream, and I can record it as it shoots around the blood vessels of the eye, giving me a measure of how quickly the blood's flowing. And what I found is that after only 4 weeks, blood flowed much slower through the diabetic retina, meaning that this starvation is already beginning. And because we know that glia control blood flow in the retina, and the blood flow is disrupted in diabetes, I predict that the glial cells are malfunctioning within the diabetic retina. And to study this further, I'm now looking at the glia and blood vessels from these same animals down the microscope in images like this one in the background to try and pinpoint the problem. And if I find one, try and find a way to correct it, preventing the progression of the disease and preventing blindness, and hopefully make this fact a thing of the past. Thank you.